Hello, this is Algebra 2, Chapter 6, Section 4, Page 2. We have this checkpoint about how to find the inverse of a function. So to begin with, I made a mistake when I made the copies. I should have crossed out some of the words here on this checkpoint. It says find the inverse of the function, and that's just dandy. We should do that. And then the second sentence, then verify that the result and the original function are inverses. That should not be there, and I'm sorry I neglected to cross that out before I gave that to you. To do that requires the use of the stuff I crossed out on the first page, and to do that requires the use of the stuff I omitted from the notes on the prior section, and we've decided not to do that. It's not part of the state standards for Algebra 2. Whatever. Moving forward, we have this function. We need its inverse. Here we go. So even though it starts with f of x equals, I'm going to go ahead and write it as y equals. And then, ladies and gentlemen, it's the time you should have been waiting for. It's the old switcheroo. So instead of y, I'm going to write x. Instead of x, I'm going to write y. And the rest is the same. X equals negative 3y plus 5. Boom. Now, the layout is not the best in these boxes, so I'm going to have to move over here. I'm going to subtract 5 from both sides, so x minus 5 equals negative 3y. And then I'm going to divide everything by negative 3. So y equals negative 1/3 x plus 5/3. Boom. Boom, boom. You think, oh, we're done. And the answer is, well, sort of. If you wrote that, you'd be okay. But if you want to look smarter, instead of writing it y equals, you write f inverse. That means to the negative 1 power equals negative 1/3 x plus 5/3. Now, this is perhaps one of the most annoying things ever. This negative 1 piece right here, that is not an exponent. It does not mean 1 divided by f of x because it's a negative exponent. It is not an exponent. It means f to the negative. No, it doesn't mean that. It means f inverse. So it looks like to the negative 1, but it means an inverse. Then I tried to fix the arrow a little bit, but that's all there. On the screen you currently see the beginning of example 3, but I've got a slightly better layout for us here. There we go. It says find the inverse of f of x equals 4x squared, where x is less than or equal to 0, then graph f and f inverse. Okay, so here we go. Let's just do the algebra piece first. I'm going to bring it back to the graph because there's a thing that's going to happen. It's going to look a little bit confusing. So they rewrote it with y equals, and then we're going to pull the old switcheroo. So x equals 4y squared. And then we need to solve for y, so we're going to divide by 4. You get y squared equals x over 4. And that's fine. Or, maybe you wrote that as 1/4 x. They're the same thing. That's not the exciting part. The exciting part then is to get the y squared. You're going to need to do some sort of square root thing on both sides. Now that's pretty tame for the 1/4. That's just what 1/2 is. And you get y equals 1/2, and you're like, oh, I got it, square root x. And you'd write, except that when you're doing the square root of both sides, you need to worry about the positive and negative versions. And now here we have a problem, because we have a plus or a minus, and just this idea of a plus or a minus ruins our idea that we actually have a function, because the y needs to be this positive thing or it needs to be this negative thing. None of this wishy-washy business. So there's a paragraph here next to the graph. We're going to ignore that first. I'm going to go to the graph, and I want to draw the graph. Now, 4x squared is a pretty steep parabola. This is the original graph. It's a pretty steep parabola. Right over here, like, oh, look at me, I'm y equals 4x squared. Okay, that's exciting. It's actually not exciting, but it's a thing. But if you look back at the original function, they say x is less than or equal to 0. And so that means you don't care about the right half of the parabola. It's only the part where x is less than or equal to 0. Now, here's the magic trick. These inverses are always flipped over the line y equals x. I'm drawing this line in black. This is not special in this problem. This is the line that's relevant in any inverse problem, the line y equals x. And we want to reflect over that. And, you know, that kind of geometry idea where you would like fold up the paper over that line and draw it. And so what you get is this line here. Well, not a line so much, actually, it's a graph. And this is y equals, we've got this 1/2, we've got this square root x business, and it's on the negative side, so it's negative 1/2, right? This is f inverse of x. So graphically, your inverse is always what you get by flipping over the boring 45-degree angle line y equals x. It's a line, its y-intercept is 0, its slope is 1. It is quite possibly the most boring line you could have on a graph that isn't, you know, just the x-axis or just the y-axis. Okay, now let's go to the paragraph, because there's a key idea here, but I think it's really important to have the picture down first. It says the domain of f is restricted to negative values of x. Okay, whatever. Actually, it's a lie, because 0 isn't negative and 0 is the domain. Don't worry about it. So the range of f inverse must be restricted to negative values. Here's the big deal. They're flubbing the negative thing, but it's not a big deal, and you might not have noticed if I hadn't said anything. The domain of f, you know what, I'm totally circling the wrong things. Sorry. The domain of f is always the same thing as the range of f inverse. The domain of a function is always the same thing as the range of the other function. The range of the inverse. It says, so therefore, and then you look at your graph, like, it would be the one with a negative in front. So it's negative 1/2 root x. And they're saying, okay, well, let's pretend we did it all over again. If the domain was positive, then our range would be positive, so we would have taken the positive inverse. And I just want to write over here on the side, you know, in the thing, that the domain, this is a big deal. The domain of f is the range of f inverse. Always, 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 always. And the converse is also true. The domain, you know what, I'm going to do it a slightly different way. The range of f remember, range is the outputs, the y values, equals the domain of f inverse. And that's also always true. Sometimes when you're looking at a graph and you're trying to decide what's going on, that idea can really help you out. You know, sometimes it might not, but that can be a really big help. Last thing on this page, this business about the horizontal line test. Oh, this is a terrible graphic they chose. Oh well, let's make the best of it. It says the inverse of a function f is also a function if and only if the horizontal line intersecting the graph of f. And the answer is more than once. If no horizontal line crosses it more than once. That's the missing set of words. Unfortunately, just those words do not help. Now, this is the same idea as the vertical line test, except for the horizontal line test, and this is why I said it's a horrible graphic, you're not testing whether or not the thing you're looking at is a function. You're testing whether or not the inverse is a function. So, if you look at this graphic, we need to fix it because it's just so close to wrong. It's frankly unbelievable. On the left picture where it says function, it should say inverse is a function. Because the picture is a function, and that's great, but that's not exciting, and that has nothing to do with horizontal lines. The fact that that horizontal line will only cross the graph once means the inverse is a function. The contrast on the right, it says not a function, and that's not even true, right? The thing you're looking at is a function because it passes the vertical line test. This isn't about vertical lines. This is about horizontal lines, which means it's not about whether the picture is a function. It's about whether the inverse of the picture is a function. So let's fix it. On the right, the inverse is not a function. That's it. That's the key thing there, and we'll get a chance to look at some examples in our exercises in class. But please fix those pictures. They need help, and I think you can provide it to them. Anyway, thank you for watching.